Welcome to Lesson 5. In this lesson, we will have a look at the operators that exist for solidity data types. The first one we will have a look at is Booleans. And Booleans have all the regular operators that exist in any other programming language. So these include logical negation, logical conjunction, which can be referred to as and, logical disjunction, which can also be referred to as or, equality, and inequality. So there should be no surprises here. Then let's have a look at integers. So integers also don't bring too many surprises. It works like in any other programming language. The first operators we will have a look at is comparison operators. So it has all the usual ones such as less or equal, less, equality, inequality, more or equal, and more. All of these evaluate to a Boolean value. Then we have bit operators. So these are bitwise and, bitwise or, bitwise XOR, bitwise negation. And bitwise operators, if you are not familiar with them, they treat their operands as a sequence of bits of zeros and ones rather than as a decimal, hexadecimal, or octal number. Then arithmetic operators that exist are plus, minus, unary minus, which is minus minus, unary plus, which is also plus plus, multiplication, division, remainder, exponentiation, left shift, and right shift. If you're not familiar with left shift, what it does, it just shifts all the bits to the left by 1, and right shift shifts all the bits to the right by 1. Address has also all the common operators for comparison, such as less or equal, less, equality, inequality, more or equal, or more. I'm not sure why you would use these. I never had to use them by myself before, but you can do that. You can compare two addresses by their equality or which one is larger than the other. Now let's have a look at bytes. Bytes, just like integers, share similar operators. So these include less or equal, less, equality, inequality, more or equal, and more. All of these evaluate to Boolean, just like in integer comparisons. Then it has the same bit operators, so and, or, exclusive or, negation, left shift, and right shift. It also has index access, so you can access an element at position k at an array x, or in this case it would be an array of bytes called x, and you can access it as long as k is more or equal to 0 or less than the length of x. So that's the length of byte array, and it returns the kth byte. And remember, it's only a read-only operation. It also has members, so you can access the length of bytes array by using .length, which yields the fixed length of the byte array. Now let's have a look at strings. Since strings are essentially arrays of bytes, which I mentioned in the previous lesson, only the operations available for bytes are available for strings. Thus, concatenation and other basic procedures that are simple in JavaScript and other programming languages are more complex in Solidity. Below is an example of simple string concatenation. See how strings have to be converted to bytes before manipulating them. Let's have a look at this example closer. So we have string concat function, which accepts two parameters, string A and string B, and it returns another string. Before we do any kind of manipulation, we convert both of these strings to bytes arrays. Then we initialize a new fixed length byte array where length equals the length of both of these strings which we had as parameters, length. Then we initialize the new variable k, which tracks the position where to append the new letter to this AB array. And uint I integer is just simply used as a loop counter. So here we have a first loop where we iterate over each letter in array A, and then we concatenate that to AB array. And then we do the same for the string B. And as you can see, we concatenate each letter or each character from array B to array AB. And then we return the new string by using type conversion. Now let's have a look at arrays. So arrays essentially have only one operator, which is index access, and it allows to access an element at position k of array x as long as k is more or equal to 0 or it's less than the length of x. And unlike bytes array, it's not just a read-only operation, you can also write elements at position k. Arrays also have two members. The first one is .length, which returns the size of the array, and the second one is .push, which only works for dynamic storage arrays, and what it does, it appends an element at the end of the array, and as a return parameter, it returns the new length. So this is it, we have seen all the operators that exist in Solidity language. Now let's move forward and explore in the next lesson how functions work. See you there!